Whereas off to the right, where we have a sample distribution, or sampling, I should say, distribution, you'll notice that they talk about p-hat for those sampling distributions down at the bottom. And then you can see that when they talk about each of the different samples, that your sample probability or proportion is a certain decimal because that many chips out of so many were red or whatever color they were looking for. A population distribution. In this particular example that we saw up there with the different graphs were the individual 200 chips. The distribution of the sample data was showing the value of the variable color. In our case, it was red that they were talking about for each of the individuals. The sampling distribution was the collection of all of the proportions. So that was the graph all the way far to the right. And all the samples have to be the same size. Just like when they're talking about a geometric distribution, you might have noticed on your test that they ask questions about is it this? Don't forget the probability, the proportion, the area, whatever you want to call it, always has to be the same. Down below here we have an example. Mars, a company that makes candy bars and other candies, says that in their M&Ms they have 24% blue, 20% orange, 16% green, 14% yellow, 13% red, and 13% brown. Let's assume that their claim is true. And look at the proportion of orange M&Ms in our repeated samples of 50 candies. So we're going to look at the population distribution. The words are a clue of what you're supposed to do. So as I look at my population distribution, probably off to the side here, how many different candies do we have? M&Ms?
50 candies.
Sorry, I meant colors. 1, 2, 3, 4, 5, 6. Good, that's close to 6. Good job. So if we talk about the blue here, I probably need some probabilities off to the side here. What was the highest one? 24?
Yeah.
So I'm going to make this 25. I'll go by 5s. 20, 15, 10, 5. And these are my proportions. And then the colors are down the bottom. I don't really have a lot of room there. So 24% were blue. 24%. That's somewhere right around here. 20% were orange. I'll write the letters down afterwards. These are the orange. 16% were green. I like this one. 14% were yellow. 13% were red. Wish I had more room here to show the differences better, but oh well. And 13% were brown. Okay, so off to the side here, the individuals, in this case, are the M&M milk chocolate candies. I'm just going to call them the M&Ms. The second thing I wanted was the variable, and that was the colors. And then the last thing that I wanted was the parameter. And we were looking for the proportion of orange. Thank you. Proportion of orange M&Ms. Okay, so in our one pack of M&Ms that Malin opened up, what you'll notice is that when you talk about this distribution of your simple random sample of 50 M&Ms, we ended up with 6 blue, 10 orange, 10 green, 5 yellow, 11 red, and 8 brown. If we were each to have a separate pack of M&Ms, our samples could all be different. That's what we talked about in the very beginning of this lesson. Okay, so the distribution of the population that we saw up above, which talked about the percentages or the proportions, is going to look a little bit different than our samples, depending on who you are. And that's kind of important to realize. One sample to sample can vary, but the distribution is talking about that population.
We should have organized it.
Thank you. So in part C here, which of these graphs then could be the appropriate sampling distribution? We taught one sample, but which one do you think is the sampling distribution and why? So I want you to take 2 minutes. I want you to think about that. Then I want you to talk to at least 2 other people, and out of these graphs, which one is the sampling distribution and why?
He's trying to get the done in this class.
Wait, when are you taking the test?
Thank you for your attention. So,
You did it all recorded.
I know, that's why I hit the recorder, Aaron. You're so clever, Aaron. Okay, so in these questions here, it's important to read and see what they're looking for. They talk about the distribution for the sample. Since in the previous stuff that we talked about, they were talking about orange. Okay? They told us that the statistic for orange was that p hat, our proportion of oranges, was 0.2. That's really important to know. Because if you're talking about the sample distribution, you know that you should be coming out with a proportion of 0.2 when you take this distribution. Now, out of all these things, John, which one do you think would be the appropriate graph?
The second one,
The second one. Why is that?
because the center is at 0.2.
I like that. So the second graph has the p hat at 0.2 for a center, which is what we would expect
Why?
with many samples taken if the claim of 20% orange M&Ms is true. Or in other words, if the company says that 20% of all the M&Ms we put out are orange, then when you're taking your samples, that's what you should see. 20% should be orange, so that should be your mean. On average, you will see 20% of the M&Ms being orange. And in your sampling distribution, then you see that your average number of proportions is highest at 20%, or 0.2. When you're describing sampling distributions, just like in our other stuff, center is a really important thing to describe. So, an unbiased estimator is when your mean is equal to the true value of the parameter being considered. So like we were just talking about M&Ms, if we take a bunch of samples and you notice that your mean is 0.2, that's good. Okay? A biased one is when it's not equal to the true mean. Unbiased does not mean it will always provide an estimate that's not equal. It's called unbiased because when you have repeated samples, like with our 500 samples, then the estimates won't be consistently too high or too low. So you might not see something that's exactly right on, but you'll see something that looks like in your distribution that it's centered to that mean of whatever the true population or proportion is going to be. Okay, so that's unbiased. Spread. Spread talks about your variability. Remember, we had many ways to talk about spread. A little bit earlier, we talked about kind of where the majority of the stuff was when we had a very first example. Spread is talking about the variability of your statistic, like our p hat, and the sampling distribution. It's normally determined by the size. So the bigger the size of your samples, the smaller the variability. There's an inverse relationship there. That's really important to know. That's oftentimes a multiple choice question on the AP exam.
What was it?
As your sample goes up, your variability goes down. It's written there for you. See? Larger samples give smaller spread. Kind of important.
Is here too.
Thank you, Aaron. All right.
So you keep talking.
The histogram below on the left shows the intervals in minutes between the eruptions of Old Faithful for all 222. I find that probably recorded eruptions during a particular month. For this population, the median is 75 minutes. We use some software to take 505 simple random samples of size 10. The 500 values for the medians, these are the medians, are displayed. The mean is 73.5. Is the sample median an unbiased estimator, and justify it? As I look at A and they ask about the sample median, we know that the sample median was 73.5, but the population median was 75. So no. They are not the same. Because if it's a true estimator, when you take a large number of samples, you should get something that indicates what the population was, and it's off. We just learned that our sampling distribution would have a spread that would be smaller because as the sample size n goes up, variability, and in this case I think they talk about spread, goes down or decreases.
I was told there were going to be two.
Okay, so as we look at the shape, the first thing that you should notice from the top right graph is that you are skewed left. So I'm going to write that down first. Skewed left. And what this means is that you know that when you're skewed, something is pulled in the direction of skewness. What's pulled in the direction of skewness? The mean. So, as the mean is pulled left, this indicates that there will most likely be more under estimates as compared to over estimates.
Asks about the median.
Okay, so the comment was it talks about the median, and as you know, as when you're talking about the median, if the true population is 75, doesn't change, but the samples will move with it. So like as your mean moves and it pulls all that data down, your underestimates will still be less than your overestimates. In fact, if you add up the totals at the top here, you check out all the bars, you'll see that that's true. Whether your median is in the same spot or not.
Don't be outliers only affecting the median.
Outliers do not affect the median, they affect the mean.
so it would not be as underestimated.